My name is Brian Murphy. I'm your room host for the day. I just want to run through a couple of items before we get started. First of all, thank you for coming. Welcome to the 2018 Public Sector Summit in Washington, D.C. The emergency exits are located, obviously, the doors that you came in through, and then behind the curtains to my right and left. Bathrooms are located out the door and to the left. Please remember to silence all of your devices during this session. It will be recorded. Those recordings will be available on the AWS Gov YouTube channel next week. If you have not done so already, please download the Summit app. We do value your feedback and do want to make this the most customer-centric experience for you. So if you could please give us any feedback that you have through that app, that'd be lovely. So without any further ado, we're going to get started here. We have continuous integration, continuous delivery, and that is going to be led by Yuri Horvath and Len Henry. So we're going to start with Yuri.
Good morning. For you security-focused people in the room, first of all, can I have a little bit of a show of hands for who in this room has had to think about security in life, or that's part of your everyday life? Okay, more than I thought. That's good. You're in the right place. So how many times have you been frustrated by the fact that your security and your compliance testing have been thought of as more of an annual event for your infrastructure or for your applications, or for the developers in the room? And I'm one of those, I will fully admit. Are there any other developers in the room other than me? Okay, we got some. So for your developers, have you ever been frustrated that on that annual basis, you might have to take a few weeks out of your life where you really want to be developing functionality for your customers, but instead you have to take a break because there's been some security or compliance rules that you need to comply with, and you need to make changes to your applications or to your infrastructure? If this seems sort of familiar, okay, so I have a few hands, then I am Yuriko Horvath. I am a senior solutions architect here at Amazon, working on with our federal civilian customers, and I'm joined by Len Henry, another senior solutions architect, working in the education space, and we're here to talk to you about integrating your compliance and your security testing into your CI/CD pipelines for infrastructure and for your applications, and scaling this out through your organization. With that, key takeaways, things for you to listen to throughout today, or at least the next 15 minutes. One of them is the benefits of automating your security and your compliance testing in your continuous integration and continuous delivery pipelines. An introduction to AWS, partner, and industry tool choices for CI/CD, security and compliance, and patterns for using CI/CD with these tools in your AWS accounts. Let's go through some goals. So developers in the room, you are always looking towards CI/CD because you want to deliver functionality to your customers faster without compromising on the quality of your code or the quality of that functionality. For the operations folks in the room, do you remember those days where you were standing up servers and other infrastructure for your applications? You were setting this up in your development environment and your testing environment, and then when it comes to going to prod, you were crossing your fingers, hoping that the same setup that was going on in your test environment, where everything was getting a thumbs up, you were deploying at that same code or that same infrastructure to production. Well, you're on AWS now. That's great. Now you can think about all of your infrastructure as code. So all of those conveniences that your developers have had around change control for their applications, now you can have that change control for your infrastructure. And with that, you can take that same code that deploys out your infrastructure to your test environment, and you can have consistency from your dev test into your production environments. With this, you're deploying out your code in a more automated fashion, minimizing those manual steps, which, there's a potential for error anytime you're going manual. And on those rare cases where something has been detected as a problem in an environment, you can always roll back to a point in time when you know your infrastructure was secure and good. When we combine these practices together of integration between your operations team and your developer teams together, we call that DevOps. And what we're really looking to focus on more going ahead into the future is for the security folks in your room, for you guys to be able to take advantage of the same conveniences in your operations teams and your development teams and start integrating in a more automated fashion continuously security for your applications, security for your infrastructure, and as you spread this across your whole entire organization, you get enhanced governance. And when we're thinking about that, we have compliance and security ops. So we're going to be looking at incorporating your security testing and your compliance testing, both for your infrastructures and your applications. But we're going to start off with infrastructure, because you need infrastructure first before you can even start thinking about deploying your applications, right? So brief overview of the advantages of thinking through CI/CD for your infrastructure and through security. And we can be taking your infrastructure as code and creating your baseline AWS accounts. So this could be setting up your networking and VPCs. This could be setting up your IAM roles so that you can have specific users authorized to do things within your environment. Or it could be setting up things like your data stores that are immutable as your application changes. In addition to that, we could be thinking about your infrastructure as code to describe your application environments as well. So this can be your blue-green deploys out to your EC2 instances, which are connecting to your immutable data stores. CI/CD has a flow, and there's multiple different tools that you can use in this flow, and we're going to go through that today. So let's start off. Again, now you have your infrastructure as code. So this could be done through CloudFormation or through third-party tools like Terraform. But basically, you're taking your whole entire AWS infrastructure, and you are describing that in a YAML or a JSON file. And now we can start doing things like committing this code using one of the tools that you see here. Going through the tools, so now that you have your infrastructure as code, you want to think about things like version control. So the three options that you see here on the screen between code commit, Git, and Bitbucket, and there are other third-party tools as well. They all support Git version control and collaboration, so you can do things like have pull request reviews for your infrastructure now. So remember, your infrastructure, it's not just always set up once. There are changes that occur. So wouldn't it be nice, as you're making changes to your infrastructure before you deploy it out, to have another pair of eyeballs or a few pairs of eyeballs to look at your infrastructure changes before they get deployed out? Well, now you can do that. Code commit is AWS's solution around committing code. It's a managed service that integrates with IAM, and it supports encryption at rest and integration with other AWS tools that you'll see today. After you have committed your infrastructure as code, you want to do something with that commit. This is an event-driven thing. You need a coordination pipeline to listen to those commits. We're going to be looking at code pipeline, Lambda, and Jenkins. And then after that coordination pipeline, again, is listening to that commit of changes to your infrastructure, and it's deploying it out into your test environment. Overall, when it comes to coordinating your CI/CD pipeline, you want orchestration across your infrastructure. So Code Pipeline is Amazon's solution around CI/CD, where it's a managed service at $1 per month per pipeline. It's easy to set up through the console or through CloudFormation scripts. So once you've set up your CI/CD pipeline through CloudFormation, this is something that you can now share across your organization to different application or workload teams. In addition to that, it also integrates with all the other AWS development tools that you'll see today. If you have a complicated CI/CD pipeline where you have conditionals, like if there is a failure over here, you might want to roll back or you might want to notify in special cases, you can look at Lambda as a CI/CD tool for you. And of course, Jenkins and other third-party tools are available in our AWS marketplace. Deploying your infrastructure. We want to look at a combination of not just deploying out, but managing the life cycle of your application infrastructure. Overall, we want integration with your CI/CD pipeline. And of course, it's nice when this is a managed service, so you don't have to think about managing a cluster. CloudFormation, Elastic Beanstalk, and OpsWorks are all solutions for you. In terms of CloudFormation, when it comes to deploying your infrastructure, it supports the majority of AWS services and infrastructure. For your developer applications, Elastic Beanstalk is a good solution. It's simple to set up for your developers. And if you have talent for Chef or Puppet in your teams, then you can look at OpsWorks for a tool to integrate there. Once you have deployed out to your test environment, you want to test. So let's get into that. So code build in conjunction with code pipeline can go through and retest your application on any changes that you've made to your infrastructure environment. And in addition to that, through Lambda or some of these other tools like Jenkins, and you're going to see an example of that in a demo today, you can go through and integrate your security and your compliance testing into your CI/CD pipeline, so that's automated for you, and you don't even continue on until you have passing compliance and security tests. Once you've successfully gone through and tested for your security, tested for compliance, and made sure your applications are still up and running correctly, you can then notify your security teams or compliance teams or others so that they can do any other manual checks before you decide to deploy out. In terms of testing functionality, as mentioned before, code build in conjunction with code pipeline integrates with a lot of third-party testing services that you may already be familiar with, including Jenkins, Nivola, Ghost Inspector, HPE, StormRunner, RunScope, and BlazeMeter. The reason why we're bringing this up in terms of testing for your infrastructure is, again, the last thing you want is to make a change with your infrastructure and for that to affect the performance of your applications or the functionality of your applications. So you can think about this as an example, changing the size of your database or changing anything in regards to your security group or your networking so that your applications can't communicate out. In addition to, for testing your security and compliance, we've got Amazon Inspector to look at security vulnerabilities for your applications deployed on EC2 instances. You have AWS Config to look at security and compliance across all of your AWS infrastructure, and it supports having configurable rules for your compliance needs, in addition to have a managed set of rules that you can look at, like the CIS benchmark. And there are third-party security tools as well that have APIs that you can call into using things like Jenkins or Lambda or other CI/CD tools. With Amazon Inspector and AWS Config, you have dashboards. So in addition to having automated testing that's running, you can always go through and look at the dashboards for Inspector and for AWS Config to dive deep into issues that are going on and recommended remedies for these issues. Once you go through and you've gone through, again, your functionality tests, your security and compliance tests, and you've gone through and your security and compliance teams or QA teams have gone and done their manual checks in addition to what's already been automated, at this point, they can give their thumbs up to say that it's ready to go out to production. And your coordination pipeline will then deploy out the same infrastructure, because remember, this is codified. You know that you're going to have the same infrastructure built in production as what you have in test. Let's look at a demo of this. So what we're going to be looking at is a CI/CD pipeline using code pipeline. And then from here, we're going to have some scenarios of security vulnerabilities that we want to remediate. So for our setup, we have got code pipeline with 2 different code bases stored in code commit. This is going very fast. From there, our CloudFormation templates are going to be copied into CloudFormation from the code pipeline, and then it's going to be deployed out to our test account, where we're going to create a stack for CloudFormation. Then it's going to be validated. And with the validation, we just want to make sure that every part of our infrastructure is set up. So as an example here, we're checking for our security groups to be set up and our IAM roles, along with our ELBs. After our test infrastructure is set up in our test environment, this is where we're going to invoke a Lambda script to call out to AWS config to look at our different config rules that we've passed in as parameters. Our Lambda script is integrated between code pipeline and AWS config. And overall, what our script is doing is starting our AWS config evaluation, going through all of our AWS config rules and looking for compliance findings. If there are any failures that are found from AWS config, we're going to communicate that to code pipeline. And upon success, we will also communicate that success scenario to code pipeline. After going through our AWS config compliance testing, we are going to now use a third-party Jenkins integration to call a script into Amazon Inspector. Let's look at our Jenkins script. So from here, what we're doing is we are making an API call out to Amazon Inspector. Then we're going to wait for that inspector to finish running. After that point, we're going to list all findings from inspector and make a report that Jenkins can read. Now let's look at our Jenkins setup. So Jenkins is configured to, of course, run this Python script that interfaces with inspector. There's the script. Afterwards, what it's going to do is read from that report that was created from our Python script and communicate what's in that report back to code pipeline. Great. So after we've done all of our compliance and security testing and our application security testing, then we're going to be able to continue on. What's our oops scenario, the security issues? One of them is we have EC2 instances that are going to be deployed out with the ability to SSH in through our username and password instead of using a PEM key. This is against our best practices. In addition to that, we are going to be missing certain tags that we want across all EC2 instances in our environment for reporting sake. And our database is going to be created without an encrypted storage volume. Oops, let's get better at that. So first of all, we're going to commit our oops scenario. And then we're going to watch code pipeline listening to this commit event and propagate the changes into our test environment. So here we have code pipeline. You can see that it's been listening for changes and it's detected some. So at this point, what it's doing is copying the changed code into CloudFormation. After this, CloudFormation starts deploying out our code to the test environment. Then we validate that our CloudFormation scripts has created our environment, and AWS config Lambda scripts have failed. So we have failed compliance. Let's fix this. So let's add those tags to our EC2 instances back. This is as easy as uncommenting. And let's go to our database description and make sure that we are using an encrypted storage volume instead of having an unencrypted database. Great. So infrastructure as code. We now commit, and we know this is going to run through our code pipeline. Changes have been detected. We'll go through this a little bit faster now. We've noticed that there's a change. We're going to deploy this out through CloudFormation to our test environment again. At this point, we validate that AWS config has passed. We fast forwarded a bit. Our Lambda script has passed. At this point, we are running through our testing through Inspector. That has just failed. So now let's look at Inspector and see what it says. So we're going into all of our findings from Inspector. And as we see what has happened, we notice that we have a medium-level severity issue around the fact that our EC2 instances can be authenticated into using a username and password. And you can see here that they have recommendations for how to change this. So let's go and fix our issue that Inspector found for our EC2 instances. So we're going to make sure that we're going to change our SSHD config files so that you can't use password authentication going forward. We're committing this change, and now we're going to see a successful run through of our infrastructure changes all the way into production. So again, code pipeline. Fast forwarding a little bit. We've gone through, we've succeeded with Inspector. Now this is where we can have manual checks around whether our test environment's good to go. I'm saying, this is passed, we're good to go. I give my thumbs up, and now we're deleting that test stack just so we can save a little bit of money in our test environment. Now we're going through into a user acceptance testing environment. And again, whoever those testers are, they can give their manual approval. And then we can go to production where, again, you can have that option to have manual approval before you ever deploy out. And we have succeeded. So now we have that same infrastructure in our testing environment all the way through production. So we've seen the advantages of having compliance and security testing for our infrastructure. Now let's look at that for our applications. Brief overview of what we want is deliver our application code and all changes to that to production as fast as possible without compromising on security for our applications. Again, now we're seeing a similar CI/CD flow, but this, instead of being your infrastructure described as code, it's your application code. What are some of the security issues that you can think about here? It could be that you have introduced an old vulnerable library into your code. It could be that you're using insecure protocols to call into third-party services. These are all things that you want to watch out for. And there is the CVE, or the Common Vulnerabilities and Exposures list, that's constantly updated for vulnerabilities that we need to check for. And Amazon Inspector is constantly looking for these types of vulnerabilities in your applications. So we take this application code now, and we need to commit it. We've already seen some tool choices there. We know that once a commit happens, it goes through a coordination pipeline of some sort to make sure that you can orchestrate the rest of your deployment out. Now, for your code, a lot of times you want to build artifacts so you can make sure that the same bytecode for your application is deployed out between your test all the way through your production environments. Once you build your artifacts, then you want to store these somewhere. And for options on AWS, you can look at S3, Amazon Elastic Container Repository, or you can be building AMIs also. In terms of building artifacts, Code Build is Amazon's solution around this. It integrates with S3, Amazon Elastic Container Repository, and Docker Hub and others. It has hooks into Code Pipeline, as you've seen, and it's a managed service with auto-scaling. There's also Jenkins and other tools that support this as well that you can find on the AWS Marketplace. Once you have stored your artifacts, this is when you can test. So when it comes to applications, you can look at static code analysis to make sure that your code quality is up to where you want it to be. Plus, you can do static code testing for security as well through OWASP. And you can do this before you even deploy out to your test environments. In addition to that, after you've gone through and passed your static code analysis testing, you can deploy out to your test environment using Amazon Elastic Container Service or Elastic Beanstalk, or going out to EC2 instances. And this is where you can also start running Amazon Inspector on your EC2 instances for looking at the runtime analysis security vulnerabilities that could be out there. Of course, once that testing passes, this is when you can notify your QA teams and security teams for any manual checks that might need to be made after that point. In terms of deploying code, we want to look at nowadays not just deploying out to EC2 instances, but also Lambda. And for those who have infrastructure on-prem, we want to support that as well. Code Deploy, Puppet, and Chef, they all support deploying out in these different scenarios. Code Deploy is a managed service that supports auto-scaling, so you can actually track what EC2 instances have what version of your code at any point in time. There's also Puppet and Chef if you have those talents on your team and you want to keep utilizing them. In terms of testing functionality, we've seen this before, but Code Build in conjunction with Code Pipeline integrates with a lot of third-party tools, including Jenkins, Nivola, Ghost Inspector, HP Storm Runner, RunScope, and BlazeMeter for a combination of doing your functionality testing, your UI testing, and performance testing. For security, Amazon Inspector, we've seen this before as well. So overall, what you're looking for in your applications is being able to comply with the CVE, so that common vulnerabilities and exposure list, and making sure you don't have vulnerabilities in your applications. You're also looking at the CIS benchmarks, Amazon security best practices, all on running instances. When it comes to your functionality tests, the tools for Jenkins and Ghost Inspector and others, they have great interfaces to show where your applications are in terms of passing your tests or diving into specific tests that are having problems. For performance and load testing, this is something we want you to consider. You don't have to do it with every single deploy out for your applications, but when major changes happen, you want to make sure that your performance has not been affected. Once you've passed your functionality testing, your performance testing, and your security testing, do not forget that. That's when all those manual checks by your QA teams and your security teams, they can give their thumbs up, and we can deploy your application code to your production environment. With that, I'm passing the clicker to my colleague, Len, and he's going to take you through a security demo for applications.
Good morning, everyone. Can everyone hear me okay? All right, so I'm Len Henry. I've spent many years doing DevOps for lots of different customers, and this morning I'm going to talk to you about how to implement securing your containers inside, as a part of your CI/CD pipeline. The example I'm going to show is containers, but as Yuri has made clear, a lot of these things depend, you have many different deployment mechanisms, whether it's to EC2, whether it's to something like Elastic Beanstalk. You can implement security with those solutions as well. So I'm going to be stopping this video at certain points as I want to highlight. I'm going to focus on 3 different mechanisms in which you can use to secure your container-based applications. I'm focusing on containers, not just because I love containers, but also because it's one of the more frequent deployment mechanisms that customers have for deploying applications on top of AWS. But many of these same techniques can be applied to a lot of different technologies as well. As Yuri mentioned, Inspector works great for EC2 instances. Config works great for all sorts of AWS resources as well. So the first example I'm going to show is how many folks hear about how often folks commit access keys and secret keys to GitHub? So for those who don't know, this is actually something where maybe once every 2 weeks, someone comes in and mentions something to me about, hey, a customer did something like this, and it's a very frequent thing that happens. So it's, we've actually, there's a tool out there that we released to the public that can help you figure this out, and it's called Git Secrets. It hooks into your Git, and therefore in your local repository, it'll be able to warn you in case someone is trying to attempt to commit something like that into a repository. So this first example is showing in using for this example, I'm showing a code pipeline, not code pipeline, but using Jenkins, and a CI/CD pipeline's running on Jenkins, and it's committing to a code commit repository. And in this example, I'm showing using the Cloud9 IDE. How many folks here have played around with Cloud9? Definitely, it's awesome. You should check it out. First thing you do after this meeting is check it out because it's actually pretty amazing. But in this example, I'm showing how I'm attempting to commit something that includes an access key, and then how it's getting stopped with Git Secrets. So here I have a suspicious config.json that includes access keys in it. And if you open that file, you can notice it does have secret key information. That's not valid secret key information. It just matches the regex, by the way. And I'm attempting to commit it. So now I'm adding it and committing it. And this is what ends up happening. And as you can see here, Git secrets actually gives you a warning, and it won't allow the commit to proceed because you have secret information contained into it. You can actually modify the scripts you use as a part, or in terms of regular expressions that it can match for Git secrets. So you don't have to look for, it actually has a built-in template for AWS secret information, but you can add your own using regular expressions. You can mark off entire folders. There's a bunch of different things you can do with it, but the idea behind it is that you don't want to, it's an example of a static analysis you can do as a part of your development process to be able to look for suspicious things that you don't want to be able to push out. So it's like, just one example. So actually to fix it, so I'm highlighting the error here. To actually fix it, you have to, in this example, I'm just removing the file. But obviously you could do things like, comment out that thing as well. So I'm actually going to trigger off my pipeline by making a change. So this pipeline is actually, or this CI/CD process is actually orchestrated using Jenkins. You could do this similarly with different orchestration technologies like Code Pipeline. The reason I'm using Jenkins is this is the next part of my demonstration is on OWASP. So one of the things you want to do in terms of securing your application, there's many different things. You can do what's known as static analysis, which is looking at your actual source files to be able to figure out suspicious things. Git secrets is an example of doing that, where it's actually looking at the file and looking for secret information. But you can actually get fairly complicated in how you do that. And actually, the plugin called OWASP or Jenkins actually allows you to do analysis based on CVEs, well-known issues with certain libraries. In the context of this example, this is a package.json that's being used for a Node.js application running inside of a container. And so OWASP, as a plugin for Jenkins, what it does is it actually looks at your package.json. In the example of Node app, it uses different files for the different formats. For example, if you're doing jars or Ruby apps, it'll look at different files, but it basically does static analysis and then basically gives you a report based off of well-known CVEs, for example, about those libraries that you're using as a part of your application. And what that's useful for is it basically highlights to you that this library that you're using to develop your application, you want to make sure you're careful about what you're doing or maybe not use that particular library. So that's the purpose for it. So I'm doing the commit into the code commit repository. And as a part of the orchestration, so there's the commit. And I'm just highlighting some of the nice things about using code commit. Obviously, whichever type of source control repository is fine as well. But this is really awesome about the way code commit allows you to do everything inside of the browser. I mean, similarly, you can pull some of this stuff from one of the things about using AWS services is that we have API hooks for everything. So pretty much anything that you can see inside of the console, you can actually pull it inside of some other using API or SDK to be able to use that information otherwise. The reason why I highlight this is that at scale, you're going to end up with lots and lots of different orchestrations. And when you're doing this at scale, it would make sense to be able to pull that information and aggregate it in order to get a single pane of glass view of your overall CI/CD processes. Because as a developer, I know that every organization has tons of development operations that are going on at one time. So therefore, as hard as you try, you want to standardize on tools, but it's sometimes not always possible. So sometimes you may have different folks using different CI/CD pipelines, for example. So one of the goals you'd want to do when you're thinking of deploying a CI/CD solution in AWS is to consider aggregation and leveraging the fact that if you're using built-in AWS services, you can make API or SDK calls, pull that information into a single source, and then put reporting on top of it using one of the many tools. A popular one is the Elk stack. So you have Elasticsearch, and then you're using something like Logstash to pull information and Kibana for a dashboard. We have a service called QuickSight, which allows you to pull stuff. If you have something stored in an S3 bucket, you can put Athena on top of it and then pull that into QuickSight. So the idea, though, is that you want to aggregate that information such that no matter how your CI/CD processes are running, you can use that information for analysis to be able to figure out how well you're doing at a high level. So this pipeline now should be triggered by the commit. In this example, I'm having Jenkins pull the code commit repository. This would work the same, and you can see here it's actually noticed the change already. And now we're actually going as it's running the build. So a couple of things I want to highlight. I'm using the example of Jenkins here. Yuri showed an example of using code pipeline. We support a bunch of different things and different ways of doing this. In terms of this example, I'm showing OAS as it's a Jenkins plugin. There's similarly other third-party integrations for code pipeline as well that do similar things. But we just wanted to show like the breadth of services, of ways in which you can do these things on top of the AWS platform. So OAS is it's a part of my build, my Jenkins build. So I'll show you the configuration for this right now. So the build is Jenkins actually figured this out, that the build is running. So it's like I said, I'm polling my code commit repository. So it's running every minute, so that's my build trigger. And then as a part of the build, so this is a container application. So it's actually doing a login into the ECR repository. And then I'm actually doing a build and publish to ECR with what's coming in for the Docker file. And then I'm actually, as a part of this orchestration, I'm actually pushing directly to ECS using the image that I just built from. And so this is an automated process. So whenever you do a commit, Jenkins is gonna see the change, push it into ECR, and then it's gonna push it out to ECS. Obviously, you can do variations on this depending on what you're trying to do. And one of the actions it's actually doing here is using the OAS plugin to display dependency analysis information of the code that you're executing. And the purpose to that, and I'll show you this right now, the next step is, that graph that you see on the right-hand side is actually the output of OASP. And it's basically doing analysis, in this case, of the package.json to basically look at things like CVEs, well-known exploits based off of the things that are included in your package.json. I just want to add that in terms of package.json for node development, we definitely recommend using an actual explicit tag for versions of libraries used, or explicit version, and not things like latest or greater than. It's one of the best practices we recommend for DevOps. And in fact, I'll be talking about that later today in a talk on DevOps. But when OAS looks at your package.json and does analysis of it based off of well-known vulnerabilities and gives you a report. So that's the dependency check actually executing. And then similar to Yuri's demo where it actually published a report output file, it's using that report output file to publish and give you a report to the users. So obviously if you're doing this at scale, those output files become a big deal because like I mentioned, you can do aggregation. So therefore, all these reports that you're doing with static analysis like OAS, you could pull them all into a central place to be able to do analysis on them to figure out how well your applications are deploying. And like I mentioned, this actual orchestration executes directly to ECS. In this example, it's ECS EC2. So eventually, it's going to push the change that I did in code commit all the way to ECS. And then this is the service that's deployed inside of ECS. And you will see I also have another service that's running, which is the topic of what's the next area I'm going to focus on, which is actually runtime analysis of an actual app service deployed in a container. If you notice here, as a part of the CI/CD rollout for this application, it's actually taking advantage of the rolling deployments feature of ECS, which is when you have a new version of an application available, it actually allows you to, and there's a bunch of different ways you can do this. You can do blue-green, you can do replacement, there's all sorts of things that ECS allows you to do in terms of how you do deployments. In this example, what it's doing is doubling, in which, and this is kind of the default behavior if you create a task inside of the console, inside of ECS, which is basically it adds a container task and then doubles the amount of container tasks depending on the setting you have for how many tasks you want maximum, and does connection draining on the old versions of the application. And then eventually, once your health check pass, it goes to the new version of the service. So that's what's happening. And then eventually, you will see that the application will get updated to match the new library that's there. And then you can also look under the deployments tab. And if you notice here, there's multiple versions of the application running. That's just because it's doing the rollout. It's just something to get used to when you're doing deployments, CI/CD using containers. So the next portion of my task is about actual runtime analysis. Static analysis is a good pattern because, like I said, you can look for things like secrets being deployed, everything else. But if you're looking to get more information, especially more information on what's actually running inside of your containers, there's a bunch of different technologies that are available out there. The one I'm going to highlight today is called Twistlock. And what Twistlock does is that as you deploy your services out onto ECS, whether that's EC2 or EKS, in this, for example, for the example of Twistlock, you can actually deploy an agent service as well that runs on your containers and does runtime analysis on your actual running container and give you information similar to what OWASP does statically, but it actually gives you a lot more, and it's actually in runtime. So this is what OWASP will give you, for example, which is based off of just static analysis. So based on the fact that you have library X, whatever libraries that you have, it'll tell you, these are the vulnerabilities, these are the known issues for that specific library. If you notice, this is kicked off by your CI/CD pipeline. So there's no work you have to do for security folks to make sure that this testing happens. So it's a key part of just trying to automate it. And like I said, our goal is to have this completely automated. So like I said, you can aggregate this information across multiple accounts, multiple DevOps processes, and then pull reporting off of it. Because like I said, for the example of OWASP, it generates a single file. And this is the type of detail. I just wanted to highlight the type of detail that you were getting from this Jenkins plugin. And it actually, OWASP will even tell you how to actually remediate the things that it finds. So it'll tell you that, hey, if you're using this specific library, you perhaps want to use only these parameters because otherwise you may open yourself up to a vulnerability. So the next two, so like I mentioned, Twistlock runs on your containers, or on your container host, just like the services that you're going to deploy with ECS. And it actually has a console that you're able to access, and that console will give you the information. The agent is known as a defender. That's what Twistlock's nomenclature for it is. And the defender runs on your services, on your container hosts, and then pulls information from inside your containers images, and then figures out all of this, some of the information that's similar to how you're doing with OWASP, but it does it at a runtime basis. I mean, you can already think of the value of why you'd want to do something like that. One is you get deeper information on what's happening. So for example, if you're using static analysis and someone, instead of using your package.json or your Docker file for doing a change to your image, actually SSH into the image and actually modifies it in runtime, you would not be able to figure out those changes using static analysis. However, using runtime analysis, using something like Twistlock, you'd be able to figure that out. And actually, that's what I'm doing is jumping over to the Twistlock console to be able to show you how much more detail you can get from runtime analysis. So this is the Twistlock console. And as you get into the console, I want to highlight a couple of things. First off, it gives you an overview of all the defenders that it has running on the different container hosts. So if your cluster, however many instances you have running on your ECS cluster, you can deploy defenders on all of them, and then you can aggregate that information into here. One thing I want to highlight as well is this is the Twistlock console. It's separate from your container host. So you could have this console looking at lots and lots of different apps spread out all across your infrastructure. So you could do this for every single app that you have running in a container across lots of accounts, lots of different projects. So it gives you information similar to OWASP in terms of some static analysis, but like I mentioned, it does this at runtime. So it's actually looking at what's running inside of your container, the actual version that's running inside your container, and not just what's in your package.json. So in this example, I'm looking in on the app, and you'll notice I know it's moving a little quickly, but it actually shows the two different versions of the app, because remember how they did the deployment? So because I had the Twistlock agent deployed on the different versions of the app when I ran the CI/CD pipeline, it'll actually show the different versions that are there. So if you look here, you'll see that there's multiple versions of my app being looked at by Twistlock. And then it'll show me, once I click on the different images that I have running, It'll actually give me details on vulnerabilities and issues associated with those running images. So there's a lot of information in here, and actually, honestly, we could do a whole talk on all the vulnerabilities, and I'll just let this play out, but it'll give you a lot of information like what's running. There's even a feature in this where you can establish a firewall using Twistlock. There's a bunch of different capabilities that Twistlock has, but at the fundamental level, what it allows you to do is to do runtime analysis on your container-based application and pull back information like this based on runtime, rather than just static analysis. And like I said, similar to OWASP, it'll give you like details on how to remediate some of the issues that it finds in the runtime containers. So that's about it.
Great. Thank you, Len. So in summary, we've seen the advantages of CI/CD, not just for getting your applications and your infrastructure into production faster than possible, but doing it without losing your security and your compliance standards that you want across your organization. In addition to that, what I want you to do after Summit is go back to your organizations, look at what security and compliance tools you're using right now, look at the APIs, think about creating Lambda scripts and your code pipelines through CloudFormation so you can already have your compliance and your security tools in a codified code pipeline that you can distribute across your organization so you have governance for your security across all applications and all of your infrastructure going forward. With that, we just wanted to say thank you. We have about 3 minutes for questions, so maybe we can only take 1 or 2 if there are any questions. There's mics. Otherwise, we are a very dynamic duo with a huge height differential. We will be outside the room also until around 12 or a little bit after to answer questions as well.
I'll be here after that, so I'll be here for another 20, 30 minutes.
Okay, thank you. Is there a question?
Yeah, question for you. As you've gone through a bunch of the teams, or a bunch of the tools, in order to remain compliant with a lot of us that have FedRAMP compliance, how would you cover these tools that you've shown us when we have compliance for FedRAMP? And I'll leave it, moderate or high. It doesn't really matter in this context.
Yeah, you definitely have to pick tools that are FedRAMP compliant and services that are FedRAMP compliant. I hope one of the big takeaways from this talk is that there are lots of different ways of accomplishing similar patterns for CI/CD process. And what you'll find is that there are solutions that are FedRAMP compliant, for example, EC2, that you can use to implement these solutions, just as long as you still have a solution for the different parts of your pipeline. And that's just the big takeaways that you'll just have to use. And the marketplace is a great place to look for that. And so that you can actually, there is a marketplace specifically targeting certain levels of compliance as well. So yeah, that's definitely something to look at in a marketplace. And we always recommend talk to your account management team. And there's always new parts of the ecosystem happening, specifically targeting customers with compliance use cases.
Thanks.
Perfect. Okay. With that, see us outside the door if you have any other questions, and thank you again.